So we're good. All right. So good morning once again. Welcome to today's class. And as usual, we're going to continue from where we stopped in the last class. So I'll just give a brief of what we did. So last week we couldn't do a lot of practicals, so it was just more of explaining. But we covered a lot of things. We did a lot of theoretical explanations, which was necessary for what we are going to be working on today. So we talked about last week we covered overflow and underflows. We talked about saturating arithmetic, wrapping around, and saturating with all of those ways of casting integers. So we talked about casting as well. So we covered casting, overflow and underflow, why we have that, how you can work your way around it, how Rust actually by default use those or undo overflow and underflow. Then we talked about methods that exist that allows you to like work around them or generally just um, make like certain or different ways of working around the overflow errors and underflows basically, whereby you can decide to use wrapping methods or saturating methods. And we talked about those, we gave examples, showed examples as well. And we talked about wrapping method. Excuse me. Okay. So we talked about wrapping methods, which is used for like generally for conversions from when you have an integer that overflows its range and it's bound, then you can use wrapping methods, and then we explain what it did or what it does, and then we explain for saturating method also what it does and how we can use that. And then we talked about casting a bit, and then we showed cases where you will use casting and different method of casting using the as or the truncation method, where you can decide to use any of them. And then before we moved into struct, right? So we talked about all of this, whereby you can typecast a particular type, an integer type into a bigger type, from a smaller to a bigger type, a truncation from a bigger type to a smaller type. And so we give those instances more like just basic ways of how they work without going too crazy, something that we can follow. And then we went to struct generally, talked about structs, gave an a basic understanding of what struct is, and from a different programming language point of view also. So whereby we kind of explain from different programming aspects using high level languages and where you may find instances of struct in other forms, like in classes, in other programming languages, and all of those things. So we did a lot of those things. We created a lot of these things last week. Created a struct that we work with. We're able to create a struct. We're able to implement method on that struct, right? We're able to instantiate the struct by creating something like this. We're able to access the field of the struct. We also talked about things like the methods on the struct, which are just the way you have it on classes. And then we talked about this self, what self is all about, static method also, and how you can call static methods and difference between a method call and a function call. So we gave all of this, we defined and we explained all of these things last week. And basically that was what we did. So I don't know if there's any question from what we did last week before we move into today, because for today's class, like we said last week also, was just to continue, we said they are going to install Rust locally because now we need to go into modules, right? And we can't really treat modules without having a like an actual local development, a file structure, right, that we can use to explain modules. So that's what we say we're going to do today. So, but before we proceed, if there's any question from all we did last week, just feel free to ask the question. Maybe anything about structs that we talked about that you didn't quite get, maybe when you tried it on your own, or anything at all. Maybe about self, about methods, and all of those things. If there's anything, please feel free to ask the question before we proceed. But if there's no question, then I believe we can start today's class fully. Okay, so any question? Let me just give like a few seconds before I move on. And if there's no question, then I'll just continue. Okay, so I assume there are no questions. So yeah, so that means everything we did so far and everything we've been treating from like 3 weeks now is very clear. So I believe what we want to treat today is basically these validations and modules, right? So before we proceed with any of this, I want us to install Rust. Like I said, I'm not going to install Rust locally so that I can treat it on this call, if so that everybody can, probably if there's any issue we encounter that you might probably encounter, we'll fix it and solve it together on the call here. So that's why I don't have Rust installed currently on this laptop. So because of that and with that knowledge now, let's try to install Rust on this device. So to install Rust, I'm going to go to Rust, Rust lang now. Okay, let me just type Rust programming language. I know we have it open here. Okay, so our agenda for today, and most probably our first agenda for today is to install Rust, right? So yeah, let's see, rustlang.org. Yes, this. So we're going to use the reference from the official Rust programming website to install Rust. So you can see this is the website. It's called rustlang.org. For anybody that is interested, let me drop it on the call. In case you don't have Rust installed, but I believe most of you already have, but just for those that do not, you can go there so we can try to install it together. So Rust language, and if you come here, you see get started. If you scroll down, you see different things about Rust. Why do you have Rust? Performance, reliability, productivity. We spoke about this in the first class, so yeah, most of us already know why. So build it in Rust. You can build basically anything in Rust now. Command line, WebAssembly, networking, embedded system. So all of these things are very important and they are critical systems basically. So and Rust is used for building all of these things. So yeah, that's all of this. So now let's go to the getting started so that we can install Rust. So now it says getting started, quickly set up a Rust development environment and write a small app. So what we want to do is we want to install Rust, and we can try without installing, which is the Rust lang we always use online before, which is this one that you guys are most probably familiar with. Yes, this one. So but we are not using this today. We want to use the actual local installation. So we are going to use something called the Rust Up. Now the Rust Up is a Rust installer and version management tool. Now generally Rust Up is just what is provided for you so that it's easy for you to just create install Rust basically on your device, no matter the device you use. So the primary way that you probably prefer installing Rust is through Rust Up, and the Rust installer and version management tool. So it's the most acceptable, the recommended way for installing Rust. So what I'm going to do is, because it's already detected that I'm using a Mac OS or Unix-based operating system, so it's going to prompt me to download Rust Up and install Rust through that approach. So what I need to do is just copy this command here. If you have not installed it, you can copy this and paste it in your terminal. So what I'm going to do is I'm going to copy this as I've done, and I'll paste it in my terminal. I'm not going to use this one. Okay, I think I'll just use this. Okay, so I'll paste this in my terminal, and you can see I have this installed. I have this pasted. So if I click on this now, it's going to start downloading the installer, right? As you can see. So this will, yeah, it's going to ask me a bunch of questions. You can see the questions are a bit much. Welcome to Rust. This will download and install the official compiler for the Rust programming language and its package manager called Cargo. Now, Cargo is the package manager for Rust. You come across Cargo, and I'm sure you must have heard of it once in, like, anytime you've been scouting online, thinking about Rust. So Cargo is the package manager for Rust, and we've used it a lot even after we are done installing it now. So Rust.up meta teacher will be installed into the Rust.up home directory at this location, and it can be modified with this if you want to change the environment variable yourself. So the cargo home directory is specified at this same directory, just like this. So you can also modify the cargo home environment variable. Now the cargo Rust C, which is the Rust compiler, and Rust.up is basically this version management to the Rust installer rather, and all of them will be available or will be added to cargo bin directory, which is at this point. So don't worry, we don't need all of these things. I'm just specifying it so that you can know what you have and what Rust is doing behind the scenes. So these parts will then be added to your path environment variables, these two, right? So that you can make use of them. So the path will be added to this one for profile and for ZSH so that you can use it directly from your terminal. Like you can call any of the cargo or Rust-up or Rust-C from your terminal from anywhere and it will work. Now you can uninstall at any time with Rust-up self uninstall and these changes will be reverted. Now current installation options for me, because I'm using a Mac OS operating system, I'm using Mac operating system, so I'm going to be using this. So it has detected my system architecture and it's already giving me like a default standard installation. So I'll just go with the default installation, not customizing it at all. So I'll just I'll just press enter just like this. Proceed with standard installation, just press enter. So I'll just press enter and then it's going to add all of this to the environment variable. Like I said, it's going to start downloading, right? So it's going to download cargo. You can see downloading component cargo, downloading Clippy, downloading Rust-doc, and all of those things. So it will make all of these downloads for me, basically. So you just need to wait for it to complete. So if you are just installing Rust, you definitely see something like this. If you go to their website and you copied this command like I did, and then you just have to wait for a bit for it to finish up whatever is downloading. So then while that is downloading, let's talk about the cargo a bit. Now the cargo like we said, we've already talked about the Rust-up, right? And we say Rust-up is the Rust installer and the version management tool. So cargo now itself is the package manager. Now, when you install Rust-up, you also get the latest stable version of the Rust build tool and package manager, also known as cargo. So cargo is the package manager, right? And Rust-up is the version management tool, right? So you see that there's a bit of difference there. So you use Rust-up to manage the installation of Rust and the version of Rust. What we mean by version of Rust is you can decide to install multiple versions of Rust on your system, on your computer, maybe for different reasons. You might be working on maybe using it to build an operating system. And for the operating system you are building, you are using a lower version of Rust. Let's say you are building a custom operating system, a minimalistic operating system, or whatever. It's just your choice. You want to build it for a project or a side project or for maybe an organization. And what you need for that kind of implementation is maybe Rust version 1.17. And then the current version is like 1.9. I'm just giving an instance now. So you can have multiple instances of Rust running on the same device, right? And you can use Rust-up to manage those versions. So that's why we call it version management tool, right? So you can have multiple versions of Rust running on the same device. So just like you can have NVM, for those that are familiar with NPM and Node.js, there's this tool called NVM, Node Version Manager tool. So in Rust, we have Rust-up, which is the Rust version manager. So, but then we have cargo. Cargo in this case is more like NPM that you have in Node, whereby you just type NPM install this, and it will just work, or NPM run dev, and then it will just work. So the same thing, the way NPM works, right, in JavaScript, or the way pip works in Python, is the same way you have cargo in Rust. So what Rust does, or what cargo will do for you is to help you manage your packages. Now the packages for every project and the build for each of those projects, so that you don't have, if you have conflict or you have dependencies that you need to resolve, probably you have this dependency that is conflicting with this, cargo can help you manage all of those things. So anything you want to install in Rust for any project, once you just type in the cargo, you have different options on how to go about installing your packages. So you don't even need to bother about package problems. So Rust comes with cargo out of the box. And once you are done installing, you can see that cargo will be available the same way Rust-up will be available for us. So yeah, let's check if our installation is still ongoing. It's not done. And as you can see, we have the latest updates, right, is on 17th. That was just last week, right there about. And the Rust version is 1.82. Right, so like I was explaining the other time, you can have different use cases. You might want to use 1.1 for your operating system that you are building, and then you have 1.8 for your actual work and normal day-to-day activities. So that's what you have. So if you want to generate a new project, let's just take a look at this. We just read this before this finish installing. And to generate a new project, we can use the cargo. Remember we said cargo is the package manager and the build tool um, for Rust, right? So that means if you want to generate a project, you can use Cargo to start a new project. You can use Cargo to install the dependencies and the packages you need. You can use it to run the project, right? You can use it to you can use it for when you want to release it for production. All of those commands are available for you in Cargo. So you can to create a new project in Rust using Cargo, which is the standard way of doing it. You just type in Cargo new, whatever the name of the project will be, and it's going to create a new directory called the name of that project you created with these files. So the files you create for you at beginning is always minimalistic, like it's always very small. It's not so large as we have in most other languages that when you install one, it just creates a whole load of files for you. So you have this minimalistic file structure that you get with any new Rust package. Now we are going to see this when this is done installing, right? And oh yeah, it is done. So you can see this is done now and Rust is now installed. Great. To get started, you may need to restart your current shell. This will reload your path environment variable to include Cargo's bin directory. Remember we talked about this the other time. And okay, so now to configure your current shell, you need to source the corresponding EMA file under it. So basically, this can happen most times, depending on the terminal you are using. This can be automatically reloaded for you without you needing to do this, right? In most cases, but for this, for my own terminal, what I will do now is I will just create a new terminal so that it can add this to my path for me. So that I can run Cargo. And to test that, I'll just open a new terminal here, a new tab, my terminal, and type Cargo version like this. So if it brings a version for me, then that means I have Cargo installed, right? Previously, this wouldn't have worked. But now you can see that I have version 1.82, which is the same version I have installed at this point, right? You can see. So I can also try Rust C to see Rust C. Also see the version, you can see same version too. So the same version of your Rust C, which is your Rust compiler in this case, will be the same version of your Cargo, which is your Cargo compiler, your Cargo package manager rather. So then you can have Rust up also. So Rust up also should be installed. I don't know if version will work for this. I'm not trying to, okay, yeah, so it works also. It also gives you the version, right? So, and you can see here, this is the version of the Rust up toolchain manager, not the Rust C compiler. So the Rust C, whenever you see Rust C, it means the Rust compiler. Whenever you see the Rust up, it means the version manager. And when you see Cargo, Cargo is just the package manager. So you can see this info here. It says the currently active Rust C version is this, right? So Rust up manages the entire thing for you. So that is that. So that definitely means we have Rust installed. So that's just it. Just one command and everything will just run for you straight up. And yeah, so now let's try using this command to create a new project that we can work with. So now what do we do? Now that we are going, I'll see into the directory I want to work with. And now this is the directory I want to work with. So I'll type cargo new, right? Using the same command. I'll just give it a new name. Hello Rust. So the same thing as what is there actually. So I'll just create hello Rust. So currently there's no hello Rust. If I check my list of files, you can see that there's no hello world anywhere. If you check the H, G, and J, there's no hello whatever there. So if I create cargo new hello Rust, you can see that it's creating a binary application, right? And automatically this gets done. Like within split of a second is done, and less than a second you can get everything. So now let's check our file structure. You can see that there's hello Rust now, and so that means we can cd into hello Rust. And then if you check this, I don't know, okay, I don't have pre-installed. So we can just check this from let's see, code, like VS Code or any other code editor you have. So if I open this up, before I open this, let's check the file structure. You can see that we have the cargo, the terminal file, we have the source, right? And if you check the source also, you can see that if you check source and then we check what is in source, you can see we have main.rs, right? So I don't have tree installed here. I will have shown you guys the structure like what you have here, right? That's the problem. So so I just want to show you guys this. Run, run, run. Okay, so basically I'll open this in code, right? But just to show you guys the structure before we open it, and then I'll use it to explain all of this. So while this is downloading, so for this structure, when we see this, you will see cargo.toml is the manifest file for Rust. Now, what do you mean by the manifest file? Now, you know that there's something in other languages, you might have encountered this a lot in most React applications, and I think that is very common, where you see something like package or JSON, right? Now, this package or JSON that you see is similar to this cargo.toml file, right? And so it is the manifest file for Rust. It is where you keep metadata for your project as well as dependencies. Now, let me show you an example of a package or JSON that you may. Yeah, let me just show you an example of this. I don't know if this is open. Let me check if this is open. Okay, it's not. So let me open an example of a package or JSON file. So this is a structure of a package or JSON file. You have this package or JSON, right? And this is a structure of a package or JSON file with name, version, type, script, dependencies, right? So you have something like this. So just the way you have this, you also have cargo.toml file having something similar. Now, then if I show this, now you can see you have something similar now, right? You can see you have cargo.toml source and main rs, which is similar to what we have here. So that's just the same structure that we have. So now let me open this in code so that you can see the structure from an IDE. So then we have this. Let me expand this. Let me increase the font. Okay. So now we have this, right? And you can see that in this file, we have other things inside, right? Basically, we have targets, we have cargo.log, and we have cargo.toml file. Now, but when we checked from the terminal, we realized that we only have two things, which is the cargo.toml file and the source, right? So if I do just normal ls, you see that target is now there. Now, target is there because a build has happened, right? So we'll get to that point. But then just to explain what the cargo.toml file is similar to, you can see it has something called package to and dependencies, just like the one I showed you here. You can see that it has name, it has version, just like you have version, and that's the name, just like you have name. That's edition. In this case, edition is not here, but then you have dependencies like this. You see it now. So the cargo.toml file is just the metadata for your project. So it contains information about your project as well as your dependencies. So the main.rs file, remember when we spoke about main.rs in when we are using the online tool, and we said the main function is your entry points to your Rust program, right? Now, in this case, now the main.rs also, okay. Now, in this case, the main.rs is also the entry file to your application, in the sense that when you have your program, right, this main.rs file is the entry points to your program. Now, as you can see, it is where we will write our application code, right? So so we've seen that cargo new generated a file. Yes, so we can use cargo run, right? And let's see what we have. So we have this file structure already, right, that was generated for us. Now let's try to run cargo new from the terminal. Cargo run, rather. Now you can see that when we run cargo run, you can see we have compiling hello Rust. I don't know if this is big enough for you guys, but you can see that we have something called compiling hello Rust, right? So this is done by the Rust compiler. That's the Rust C that we saw the other time. So now this is handled by the compiler, the Rust C. It it's compiling the project called Hello Rust, and the version of that project is what 0.1.0. Now going back to the manifest, you can see that it's actually making use of the version we have here, 0.1.0, right? So now that is what it uses, and so that's why you need the metadata, the cargo.toml file, because the compiler uses that for all his own specifications and his own need to run your code and compile your code. So now another thing we will need to see here is this dev profile. Remember we spoke about profile that day. Remember we spoke about dev profile the other day, and while speaking about dev profile, I talked about you having different profile in your Rust program, right? Say you have like the dev profile, you can create other form of profile. And the reason for profile generally depends on your use case, right? So you might want to have different profile for different reasons. But then we said, I just told you guys that you will see it when we start working locally. And so basically this is it, right? And we'll still talk more about it, but for now, just know that we have this profile and it is something that is being used also during compilation time. And so you can see this. So after compiling and finished running using your dev profile, which is the unoptimized one, and then you can see this running this particular one, and then that's this target file that you have, and then you display the result. Now this result is the one contained in your main.rs file, which is this. Now remember that we already have our main program, which is the entry point to our Rust application, like we said already in our previous classes. So that means whatever is inside here is what is displayed on terminal. So if you want to just test it out, we can do this, then run this command again, cargo run, and then to build again, to compile everything, and then you see the new result. Now, this is similar to what was happening when we're using the online editor. The only difference now is that when using the online editor, everything is done online for you and compilation happens. So you don't get to see all of this informations, right? But now that we are running locally, the informations are there for us to understand what is happening. So as you can see from here also, it says you will see all of this and we've seen it. So now how do we add dependencies, right? So say we want to add a dependency to do something, whatever. It might just be a dependency for, or a library rather, for you to manage strings or to manage fonts or whatever. And you want to add the dependency, which you are still going to do. But then this is how you can go about it. You can add this to your cargo.toml file, or you can use cargo add then the name of the package. Right. So it depends on whichever works for you, but most people tend to use the version, and I think it's preferable so that you can stick to a particular version that you want to make use of. So you are not using a lower version or an higher version. So yes, so this is basically what we have. So if I do this and I add this to my dependency, so let's say I go to add this to my dependency in cargo.toml file. Remember, it is empty currently. If I add this to it, I'm simply saying that whenever I run this program again, let me clear the terminal. And I run this program, Rust should download whatever dependency does not exist in my cargo.log, because my cargo.log is what will manage whatever I need for me, right? So now it's not like the log file that is not meant to be touched by you, it's auto-generated. But then the cargo.toml file specifies the dependencies you will need. So now let's say I run my cargo run again. Where is that? And you can see that it's compiling all of these things. So all of these things you see compiling here, right, are just the dependencies of this pharisees. Now, if you go check the library called pharisees, you will see that all of these dependencies are there. You can see it's installing Unicode with Smoke, Smallvec, Textwrap before it's installed the app itself. So all of these are the dependencies of the app, of the library rather, before installing the library itself and before compiling my code, because my code depends on the library to function, obviously. So that is what happens, right? So you can see the way everything works and everything connects to one another. So so from here, basically, so what we have now after this is, before we start working with modules, I just want to like brief you guys on all the commands that we'll most probably be using. And yeah, one last thing. Remember we had something like this for structs. That was last week when we talked about struct. I'll talk about importing, calling, making a function call or a method call, right? Remember we said, and we have this. Okay, we have this kind of format, right? So now, in this case, now when you see something like this too, it's just more like you're using it to import something. Now, if you remember from, let me try to open the file. Let me try to reopen that playground. I know we added it to the playground the other time. So remember from the playground we had this call, this kind of call the other day, which is where is it? Yeah, we have this the function call and the method call syntax, which is this, and then the function call syntax, which is this. Now, which is something like this the other day, which is this double colon, right? So now this is also using a double colon, but this one is a different one. So now to use the dependency we added, right? It simply means that we are going to need to use the dependency we added now, which is the Pharisees, and we have already installed um, from our terminal, which we can see here. Now we can open main.rs, which is the main dot Rust file that we have, which is what we have here that we've updated the other time, and we can remove everything that's in there. Do you get? And add just this line to it. Now this is just an example, right? We are still going to do actual stuff. So if we do what they ask us to do here and run this, and then we save. Now this line means that we can now use the save function from the Pharisee create export for us. So now this is going to come in handy when we start working with modules, because this is basically how you'll be using your modules. So the reason why I'm pointing this out is so that you can see how external libraries are being used. So, and this is an external library, right, that you can import a particular method from called, say, a function in this case. So you can import this function from it, right, which exists inside of this crate, right? So now it means that you having this use syntax here means that you are making reference to a library. That means you are making reference to a module, one way or the other. So just take note of this, because when we go into modules and we start creating files and using it, we are going to be using this same syntax for our own implementations. So that's basically. So now we can use this application. Let's say we write this application and let's see. Let me just copy this, right? Because it's just a sample code. Don't worry, we'll clear it off. We are not using it actually. So if we do this now and then we run this code, let's cargo run this. Then you can see that it's compiling as usual, doing this, and then you can see this on screen. Hello, fellow Rust stations. So this library is what is doing this for us, right? The library called what fairly says. So you can see that say is being used here. Let me reduce this. And you can see what is happening here. So let me expand this a bit. We have fairly say that is imported, right? And when we imported this library, remember we installed it, and then we are importing it like this, calling save from this Pharisees, and then we are using this standard input, standard library IO that Rust provides for us by default, and then we are getting standard out, which is what prints to the console, like what you have here. And then we have this message. Remember, we talked about string, but we've not used it yet, but we mentioned it and we used it for struct last week. And then you can see string for hello fellow Rust station, and then that is what you see at this point. Do you see it now? And then you have the width size for the characters you want to display. So basically what this say thing does, this say library that we have, right, is the one creating this for us. And you can see it is the one creating this kind of structure for us. Do you get? So it's a library that does this already, written by someone, deployed to the Rust create repository, whereby you can just pull it and install using cargo, and then you can make use of it. So now this is an example of where module comes in, because this is an example of a module written by someone that you can make use of, a library written by someone, most probably divided into modules, right, that you can then import and make use of as you want to within your program. So that's basically like just the structure of how we will use modules now going into it. So yeah, so as you can see, everything works the same way it works here. So now that we are done with the example that we are given from the actual website, now let's try going back to our own resource and using that to continue our own learning today. So let's talk about the modules, right? So for the validation here, this one is just talking about how we can validate our string. So no, like I said, we always come back to the previous exercises when we've learned what we need to tackle it. So for now, we'll just move on because we need to learn about a few things before we'll come back to this. So let's go to modules, right, which is like our main activity for today's class. So what are modules, right? Let's just see what is here. So a module is just a way to combine codes together. So basically, say you have a file, and then you have another file, then you have another file within that file, and then before you created those files, you have everything in one file before. Say you have like 1,000 lines of code within this main.rs, and what that does is just it's is more like it has multiple functions, and those functions can be abstracted. You can more like move it into their own components or their own file, or their own file, so that you can just import it directly, which is good for structured code, right? So in this case now, that is what a module helps you to achieve or accomplish. So it's a way to group related codes together, code that work the same, like they need each other to work, but then you don't want to put it in one particular place. You just want to separate concerns so that it's easy for you to work with, and probably if you are working with a team, they can easily understand what is going on too. So it helps you to like modularize your code. So that's the idea for modules. So it's for modularity, and so that is it. So it's a way to group your code together and under a common under a common namespace. That is the module name. So we'll see what that means, but let's read this from the beginning. So the new method you defined is that's from the validation side. So let's just move on with this. So what is a module now? A module is a way to group related code together under a common namespace. Now we'll see what a namespace is, right? So a namespace is just the module name. Now you've already seen modules in action. The unit tests that verify the correctness are defined in different modules named tests. Now there are different types. We have the inline modules, right? But if you look at the test we've been using from the GitHub, we want to always tell you guys to like try out yourself. You notice that there are different. You see something like this there, mod test, right? Now this mod simply means you are talking about a module. That's the meaning. So like I said, everything in Rust is kind of literal. You see it, you probably know what it means. And so you see mod test in this case, and that means you are defining a module. So now that's why you see them within the same, you will see them like in a library, like something like this. Something like this. You probably see this, mod tests, right? That's because this text is a module, actually. So, but because you can't see it here, you get it now. But then because we are using that mod keyword, don't worry, we'll still look at all of those things. It just means that you are referencing a module. So now let's look at inline modules. The test module above is an example of an inline module. It means that what the module declaration and the module content are next to each other. Do you get now? So this is the module declaration, which is this. And remember that whatever is inside the curly bracket is what is defined within the scope of what it was defined from, which is a mod test. So in this case now, you are talking about an inline module in this case, right? Because you are defining the module, and then the content within the curly bracket, which is the scope of this test module, is defined here. So these are what we refer to as inline modules. You see now, everything is inside the mod test. So that's an example of inline module. So now we have the module tree. Now modules can be nested, forming a tree structure. Remember the tree structure I showed you guys from here when I talked about tree? Here, and then I showed you guys, you can see this tree structure now, it has grown bigger than what we had before. So let me just remove that. So then it basically means that you can have a module of that structure too. Sorry, come again.
I think the screen is frozen.
Oh, it's frozen. Sorry, can any other person see it, or it's frozen from their side too?
I think it's the network. It's not frozen.
Oh, okay. So please just check your network, probably refresh or something. All right. So talking about modules, right? And modules can be nested, forming a tree structure. The root of the tree is the crate itself. We talk about crate. No, we mentioned crate twice now. Now we'll talk about it too, which is the top level module. So the crate in itself is the top level module that contains all the other modules. So say for instance, you have something like this. Let me give an instance now. Okay, there's not really much example to show you from here. But then say you have, let's say I have a folder here, and I call the folder name me, for instance, and then I have a file in this name me called name.rs, right? So and then inside this name me, I have another folder and I called it person2, right? And then I have another file called person.rs. Now in this case, what we are referring to is that see there's a top level, right? There's a top level. Even if you open this, you can see that there's a top level here, and the top level at this point is name me, right? And there are nested codes within it. So now when we refer to the top level module that contains all the other modules, that's what we refer to. So in this case now, name me is the top level module that contains other modules like person2. Do you get now? So it just means the way we arrange them in terms of hierarchy. That's basically what it means. So for a library crate, the root module is usually source lib.rs unless its location has been customized. Now, the root module is also known as the crate root. Now, we'll see all of these things eventually. The crate root can have submodules, which in turn can have their own submodules, and so on and so on. Just like I have this here. Yeah, so you can have nested modules like that, like that. So we have external modules. Aside from the inline modules that we have here, that we've shown, and that we've seen an example, we have external modules also. Now, inline modules are useful for small pieces of code, but as your project grows, you want to split your code into multiple files. Now, in the parent module, you declare the existence of a submodule using the mod keyword. Remember the mod keyword that we saw here also, right? And like we said, the mod keyword is used to specify that you are referring to a module. The same way you have your fn keyword to specify that this is a function, right? And the same way you have your struct to indicate that this is a struct, and your implementation to indicate that this is an implementation for the particular struct that you have the name after the implementation. So you can have all of those things. And then, okay, so you can have all of those. And sorry, let me go back. Okay. So now that is just a way of indicating that this is a module, right? So you have the mod keyword, and that's that. So now let's look at the examples we have here. So cargo, this. Okay, so remember we have cargo, and we said cargo is a ROS build tool, like, and is in charge of running your code, building your code, defining your profile, releasing your project when you are done with it. You can use cargo release to like release it for public release and for production release. So now cargo is useful for all of those things, and then it's in charge of finding the file that contains the module implementation also. So it's always good to know how the file structure in Rust work also, because when you start working with a lot of nested modules, you can have a bit of issues if you don't fully understand how it is. So Rust helps you to manage those things, yes, but still you need to also know what how you are structuring and creating your modules to avoid issues for yourself at the end of the day as a developer. Now, if your module is declared in the root of your crate, let's say for instance, you have a source lib or source main, cargo expects the file to be named either source/module.rs or source/module.mod.rs. Now, we'll look at this also. So if your module is a submodule of another module, the file should be named something similar to the parent module and then the module name. Right. So we'll see all of these things as we proceed now. So now let's look at an example. Item paths and use statements. Now remember we've seen the use statements when we showed the example here the other time in main.rs. I showed you guys the use statement. Now use is more like we are saying import something for me. That's basically it. So we are saying use this file or this function from this file, from this file, from this file, which simply means use this function from this module that exists here, here, and here. So that's the meaning. So you can look at the use like an import statement, basically. Now you can access items defined in the same module without any special syntax. You just use their name. So let's say, for instance, now you want to call this. No, we've not used the use function since, or the use keyword since we've been writing our project. But now that we are dealing with modules, we will most probably need it. Now, this you can't just, so when you are working with multiple files, right, you will want to now start using the use keyword, right, a lot, because now we are making imports, right? You are making reference to files that are not in the same file that we are working with. So you can compose the path in different ways. You can start from the root of the current crate, which you can see something like crate module 1 my struct, or you can start from the parent module, which is super and whatever the function name is. Then starting from the current module, you can just reference the submodule and then the struct name if there's a struct in the file. Now, I know this all seems like there is nothing happening here, but these explanations are also useful, right, for many reasons. And when we start using them, you see that I'm just rushing through them because you can always make reference back to them. But it's not as if we want to spend all our time talking about it. So having to write the full part every time you want to refer to a task can be cumbersome. Now, to make your life easier, you can introduce a use statement to bring the entity into scope. Now, let's say you want to bring my struct that is contained in a module one, that has a nested module called module two, and then a struct in the module two. Now you can just import like this, and then you can refer to it directly. Now there's something we also refer to as star import. Now star import is when you want to import all the items from a module. Star simply means all of this, right? Like everywhere you start using like anything programming, it simply means all. So when you use this star, you are simply saying that I want to import all the items from a module. So let's say you have this module one, and it has a nested module called module two, and then you have, let's say you have struct in the module that you mark as being used outside of that module, and then you have other things like functions and all of those things. You can even use the star imports like this. You are making reference to, or you are able to import and make use of every single data that is inside, or every single item within that module, be it a struct, a function, whatever is there that you need to use. So it is referred to as a star import. Now this is discouraged, right? In every language it's always discouraged, but still at times you use it because it makes your life easier. So it is generally discouraged because it can pollute the current namespace, making it hard to understand where each name comes from and potentially introducing name conflicts. Nonetheless, it can be useful in some cases, like when writing unit tests. You get it now. So it's always being used most times. So there's no way you want to don't say we'll use it. Now, so there's something we need to do, right? Of course, we've read all of this, we've done all of these examples, and then we can probably go to visibility. But for the sake of probably using an example to explain this properly, I would like us to use the Rust book, which is the Rust. No, not Rustling. The actual book itself, Rust book, where are you? Okay, so where we have the Rust book itself, so we just pick the modules now, right? So you can see it's probably in chapter 7, right? We should have talked about ownership, but then for us to start talking about those things, let's have a structure first before we go into ownership and start talking about borrow and all those things. So now basically, I want to pick an example from here on how to use those things, like so that I can see them actually work. Defining modules to control space. I hope this one is simple enough to work with. Okay, so now let's look at this example, right? So let's say we have let's create a new what they call it now. Let's create a new project, right? And just for this test, for the sake of running this and seeing what is being explained here. Now you can see that most of the things we have here, we've already talked about it there, as we will see, right? We'll still come back to it. But let's just try to run something first. So I'm going to go back to the main one, and then I'm going to run cargo. Remember, we use cargo new to define our new project, right? So in this case, we want to define a project called backyard, just like in the example here, and then I'll call it backyard. Right, so when we define cargo new, I will seed into backyard, and then I'll open this code also. And okay, so it's opened here. I can see it here. Okay, so I'll close this. I don't need all of this, guys. So I'll expand this again, and then probably minimize this. I don't need that for now. And then move this to the right hand side, and then yes, so now I have this just like this. Now, using the example from this book, right? Now, you can see they have the structure, right? So I'm going to read some things to you guys here about the visibility. But then, before we talk about visibility, let's just even see what they're talking about. Now, but before we go into that, now look at what is being talked about here. It says, before we get into details of modules and paths, we provide a quick reference on how modules paths, the use keyword, the pop keyword work in the compiler, and how most developers organize their code, because that's the essence of the modules, right? We'll be going through examples of each of these rules throughout this chapter, but this is a great place to refer to as a reminder of how modules work. So definitely, like I always say, we'll make reference back to previous implementations and previous documentations when we need them. So start from the crate root. Now, when compiling a crate, the compiler first looks in the crate root file, usually the lib or the main.rs for a binary crate, the lib for a library crate, the main for a binary crate for code to compile. Now, for you to not declare your module, how do you do it? I've already shown an example of how to declare modules the other time when I was talking about this this one. So just a folder that you define. You define a folder within the source file, within the source folder, in the same path, in the same root as the main.rs. Now that is why you define your modules. So, but let's leave that aside. So let's just use the new one. And now in this new one, now it says you create your module, right? It says you create your module with like creating a folder. So let's say in the create root, you can declare new module. Say you declare a garden module with this. The compiler will look for module code in these places, inline, like we explained, in the file garden.rs or in the file garden/mode.rs. So what this simply means is that okay, let's just continue. So now let's declare submodules. Like in any file other than the create root, you can declare submodules as well. So let's say, for instance, you might declare your mode vegetables. All of these things are just storage. Let's just create one. You understand what I'm talking about. So we have the source and we have the garden here. So now let's try creating this. Now in this source folder, you will realize that they created a garden first of all. Now, if you look at the tree, using that same approach I did the other time, if you look at the tree now, the tree is not too long. Okay, that's compiled when I went code. Sorry. So, but now you can see that let's create a folder inside of this and let's call it garden, right? That's what we want to create based on what is here. And then we create vegetables inside the garden. Vegetables.rs. Now, in this vegetable.rs, now we've simply created a module of called vegetable. Now, just try to follow along. Then you see that there's another garden here defined. Right now, what did they do here? You can see, let's create the garden too. Let's create the garden file within our source file, right, before we start explaining this, so I can follow along with what is also there. So you can see that we have the same structure as what is here. We have the garden folder, we have the vegetable.rs within the garden folder. Now we have a garden.rs outside of the garden folder. Then we have the main.rs also. So now the main.rs is your binary file, right? We know it's the entry points to our project. We already understand. Now the create root file in this case is what? The main.rs. Now it simply means, remember we said there are two, you can have two main root file. You can either have the lib.rs, you can either have the lib.rs or the main.rs. Now when the lib.rs is not available, the main.rs becomes the root of that crate. Now the crate in the sense of this project that you're talking about now, because if you release this as a library, it becomes a crate at the end of the day. So now this library that you're talking about is basically like, it's going to be used as the root of the crate if it exists. But in this case, say we don't have it here, right? Now the main.rs is going to be the root of the crate, and that's what this is referring to. Where is it? Yeah, we mentioned it in the first one also, in the first one, where we talked about the root of the crates. Where is that? So I'm just trying to look for that so I can make reference to it. Okay, yeah, so this is it. If your module is declared in the root of your crate, which is this or this, Cargo expect the file to be named either this or this. Do you get? So the root of your crate is usually either the library.rs or the main.rs. Do you get it now? And it also said here at the same, so it says you can declare, like you start from the root crate. When compiling, the compilers first look at the crate root, usually the source lib.rs for a library crate or the main for a binary crate. Do you get now? So that's basically what we are referring to here. So now in this case, we don't have the lib.rs. So in this file, in this crate now, this is our root crate, the main.rs. Now going to this, to the next thing. Now the create root file in this case, let's just copy this code and paste into the main.rs so that we can replace what is here. Now let's now observe the structure of what is here and try to understand it. Now the first thing we see here is that we see the use keyword being used, right? Let me reduce this a bit. Now you can see that we have this. What did I write here? Did I call it vegetable? Okay, yeah. So let me close this. So you can see that we use the use keyword also. Now what does this mean now? It means that we are trying to call something called asparagus. That means asparagus exists as a struct, right, within vegetables. Now, how do I know it's a struct? Because of the way it is defined here. Do you get it now? But then, remember we defined the garden in this case. Now, the garden is coming from where? This this folder here called garden. Now, then we have the vegetables inside of this folder called what? Vegetable.rs, which is where asparagus is supposed to come from. Now, you can see there's an error here, and it's telling you that cannot find vegetables in garden, unresolved import. So that means we can't even fetch this asparagus because we do not know what the result is. You get now? No, we are still coming there. So now, analyzing this, you can see that we are now creating our own modules using this file structure. We are creating our own modules, which looks similar to the file we exported the other time. We imported the library we imported. So that means it was probably created using the same approach. You get? So now, I'm sorry, is this clear to anybody? Is anybody confused? Because I just feel like I'm talking since. Is it clear to you guys? If you guys are not too lost. Okay. All right. So now in this case, now say we have the root creates, which we understand to be the main.rs, and then we have this file. Say we have this file right inside the main.rs. Now let's now look at what is here. The pub mod called garden here. This line that we have here. This one here now. Remember we said this mod means what? We are making reference to a module. Remember we said that, and then that means we are making reference to a module called what? Garden. So that means there's a module called garden somewhere in our folder structure. Now, the pub mode garden tells the compiler. Now, I'm purposely skipping this public because I've not spoke about visibility yet. So, but we'll come back to it. So then the pub mode vegetables here means that the code in the source garden vegetable.rs is included too. Remember I said this here. This vegetable that was defined. No, we defined this already now. Now let's look at what it's saying here. It simply means that because we are making reference to this mod vegetables here, vegetables is where now is inside this place is included. We are simply making reference to that file. Now, and the code inside that file is what? Is a struct. Remember I said it's a struct, right? Because of the way it was used here. Now that means let's copy this code, or in fact, let's even write it. So let's write the code called this inside the vegetable, right? And let's say derive. So we'll talk about what these derived guys are eventually, right? Yeah. Pub struct as paragraphs. So we simply define a struct. Right? Remember the structure, the way to define a struct is just to use struct like this, right? But you see that there's a pub here. Now this pub is also, you can see that there's also a pub at this point. Now we'll come back to those ones, right? But for now, just try to understand what is happening for now. So now from the main.rs file, which is the one that is making the import, and you can see that we already specify the garden at this point. Now the pub mod garden, like we said, is telling the compiler to include the code it finds in garden.rs. Do you understand? Which is what is inside here. So now that means inside garden.rs, which is this, we need to add this pub mod vegetables so that it can make reference to what is inside of this place. Okay, let me take that again. So now let me remove this, right? Leave it as it was before. If you go to main.rs, you see that this is complaining for some reason, right? It says unresolved imports, but you specify that your mod, your garden is a module. You get now. And then remember they said here that the pub mod garden, this line, the same line that we have here, it's telling the compiler to include the code it finds inside of this garden that we defined here. That's garden.rs. It's telling it to include it inside this main.rs so that you can use it. Now, so that means that this garden.rs now is where we need to define the module I want to make reference to, or the file we want to make reference to rather. So what we need to do there in this case, we need to define this vegetable that we already have here also as a module within the garden.rs. So now remember that this pub mod garden is simply telling the compiler to include the code. So what it's just doing is more like a copy paste. Do you get now? So we are simply saying using this main.rs, this line here, we are simply saying copy whatever you find inside this garden here. And garden here is not the folder itself, it's the file itself. Now the file will tell you what to get from the folder. I don't know if that makes sense. So you are not making reference to the folder directly. You are making reference to the file, but the file will tell you what to fetch from the folder. Now, the moment we define this, remember that before we define this, we get this error. But the moment we define this here, right, we no longer get that error anymore. Why? Because Now the compiler understands that within this garden that we define, which is garden.rs, we are saying that fetch vegetables.rs as well. So it simply means we are making reference to our modules, but we have the liberty to specify that this module should be used, this module should not be used. So that's basically what is happening here. I don't know if that's clear to anybody. The last explanation about the file being the one specifying what to fetch from the directory or the module. All right, go ahead, Olusoji. Question.
So I wanted to give a thumbs up.
Oh, okay. All right, so that means that is clear then. So, yeah, so let's proceed now. So now you can see that inside the vegetables, we have our struct that we already mapped public. Now, we've already understood what we have in the struct. So that means all the files we have here, before they didn't have anything inside of them, but now we've defined content inside of them, right? And that way, you can create more things here. So let's say we want to create fruits.rs, not ts, come on, .rs, right? And then inside this fruit.rs also, we can create another struct. We can create another struct and call it fruit. An empty struct, right? Just like we have for vegetable too, asparagus. But in the fruit, you can call it, let's say orange, or let's say mango. Let's for start. And then inside the vegetable, just like we have this, right? We can do the same for here. But then we can also add the pop. Okay, I don't want to do that. Let's just leave this for now. There's a reason we'll come back to it. So now let's get into the details of these rules and demonstrate them in action. Now, grouping related code in modules. Now, we already understand that modules help us to group our codes together, right? Organize the code within a crate. Remember I said that in this case now, this is your crate. The entire folder, the entire thing you have here is your crate, right? And that is why this is referred to as your root crate, or your crate root in this sense, because everything that when you deploy this, or let's say you like push it to Rust crate repository for other developers to use, it's simply just a bunch of files that you've created with logic and explaining and defining how the developers can import and use them, or more like inherit them and then update them or stuff like that, depending on the logic you have in your code to do. So now, in this case now, we already understand that modules help us to group and organize our code for readability and easy reuse. Now, modules also allow us to control the privacy of items. Now, we've not spoken about visibility. Now, let's talk about visibility a bit. Because now that we remember we have pub here, right? I remember that almost everywhere within the code we have pub, right? Now, I won't start with the pub that we have here. No, I'm going to start with the pub that we have in the last file that we are making reference to. So I will remove this pub here. And when I remove this pub, you see that there's a complaint here also. And this is complaining. And the complaint here is that it's private. Do you get now? So it simply means that whatever you define in modules are private by default. Do you get that? So that means this vegetable that you see here, the vegetable.rs, that is defined within the garden, right? That you are specifying that this garden should fetch. Even though you are specifying that this garden.rs should fetch the vegetables from this folder here, you are not specifying vegetable to be used outside. It's just more like in JavaScript or TypeScript, whereby you don't export a file and then you want to import it. It's definitely going to throw an error, right? That's the same thing happening here. So like I said, it's just an import. The use that we see here is an import also, just like you have in other languages. But in other languages, we call them imports. But in this case, we call it use. Do you get it? So now, given this that we have here, so now we already understand that from this explanation, this is private by default. Like whatever you have in your modules is private until you explicitly state that you want to use it outside the modules. So that means if you remove the pub like we have here, it won't work, right? So in this case now, this fruit that we define here won't even be able to we won't be able to use it outside of this garden folder, because we didn't mark it as pub here. You get, so we just mark it as just struct without public. So now the pub simply means you are marking it as public, right? If you see this place, this pub now means you are marking it as public. And so the issue of it not being visible in this case, just like you have here, you have this error here, will not come up again. Because now you say struct asparagus is private, right? It's a private struct, but now you've defined it to be a public struct, right? So that's basically what happens. So now, let's now proceed from there. So that means private items and internal implementation details not available for outside use. And so we can choose to make modules and the items within them public, which exposes them to allow external code to use and depend on them. So which was what we did within this vegetable.rs, right? So we just made it public here. Now, as an example, let's write a library crate that provides the functionality of a restaurant. We define the signature of functions, but leave their bodies empty to concentrate on the organization of the code rather than the implementation of the restaurant. Now, in the restaurant industry, some parts of a restaurant are as front of house and others as back of house. So now, basically what they're talking about here is we can create a library crate, right? Remember what we mean by library crate now. It simply means you create a library in your source file like this, live.rs like this. This is a library crate. This is a binary crate. The main.rs is your binary crate. The lib.rs is your library crate, right? So it simply means you can create the library crate. Right? You can create a library crate that provides the functionality of a restaurant. You will define the signatures of a function, but leave their bodies empty. So let's see an example of what they are talking about. So in this case now, some parts, so we can define two things in this crate that I want to talk about. We can define the front side of the house and the back side of the house. The front side of the house is where people will be, the customers. The back side is where the food will be prepared and all of those serving will be done. Now, to structure our code in such a way, right, to model or to simulate this kind of restaurant, right, we can do it in such a way that we have this mode, front of house can be a module. The back of house also can be its own module, right? So, and then let's see what they are talking about here. So we can organize our function into nested modules, create a new library called restaurant by running cargo new library stuff. This is how to create a new library, right? It's using cargo, that's the meaning. They enter the code in this to define the modules and function signatures. This code is in front of house session. So we can define this, right? So let's say this is what they're talking about now. We can define a new project, call it front of house, hosting, then serving, like something like this, right? Without having a binary crate. We just have a library crate, and it works also. So this is just another example of how you can have your code structured. And if you look at this, you can see that it simulates what we have here. We have this front of house now, which is a module, right? So it's a nested module. So this is a module that has a module that has a function. So this module called front of house now is a module. Inside the module, you have the module called hosting, and then you have another module called serve. Right? So now the thing about module is that yes, it can get confusing. Yeah, it can actually get confusing. But then the more you use them, the more you tend to like understand it. And that's why I'm taking time to like give you this simple structure, because at the beginning of using modules, you probably want to stick to one particular structure. Because if you want to start using inline modules or external modules, it might get a bit confusing to you, and then you just lose it. But then you can easily understand it without like worrying too much about. Just pick one that is clear to you, make use of that one well. And when you understand it, you just flow to the other one as easy as possible. So that's why I prefer this approach. And I think this approach is what is common to most people and most projects. So that's why this is what we are sticking with, right? So I hope this is clear. This particular backyard thing in terms of defining the modules. Let's say we want to import something from a place, we know what to do, we know to make it more like a public function, all of those things. Yeah, Clemens, you have a question.
Sorry, that was an accident. Sorry.
Oh, Collins, rather. So do you have a question?
Yes, I do actually. Good morning.
Yeah, please go ahead.
So my question is, if you use that library module syntax, would you still create files that have those code?
Yeah. So if you are creating, say you are using a library crate, right? In this case, you can still create this way. It just depends. So that's why I was explaining that you don't necessarily need to use inline modules like this. You can create your own modules as external modules, right? Just like we have here, this kind of structure. So you can create a folder, put your code inside the folder, then you can import it from, you can import it in the main file from anywhere. Do you get? So let me just show another example here, basically. So inside of this place, so let's say I have house.rs in this place. Now house.rs, I want to use something from house here, right? Let's say I want to import it, create house, and I say door, and inside door I have, let's say, chair. Just an instance, like we are just playing around with stuff. So in this case now, how do I reference something like this? Now let me expand this so we can have more room to it. Now if I want to import something called chair, right? You know that at this point now, how do I create a file to match this kind of import? That's the question, right? So what we need to do first of all is we need to have this house dots. You need to have something called house. In this case now, we need to have a file inside of source called house, like I've defined here, right? That's the first thing you do. Now you need to have a door inside the house. Remember in the garden too, we have something like this here. So we need to have the same thing for house. Then going back to the main file, we need to have a door inside. So we go back to our house and then we use a pub mod door. But remember that we don't have door created anyway. So it doesn't do anything right now. So that means we need to create a folder here called house. Do you get now? That matches this. Remember that we already have house.rs here. But we need to have this house here. Then we need to create something called the door.rs. That's the door you are making reference to from here, the module. So you need to create the module inside here, and then you can now define whatever you want to have inside this door as check. So let's say you want to define it as a struct also, right? And then you want to implement something for the check. You get? So in this case, you can define it as public in this case, and then you can derive, don't worry, we'll talk about this eventually. But at least for the first time, everybody just crams this and use it. So, but then the idea is if I want to import this now, I can do this, right? And you can see that there's still an error here somewhere. What's the error? Let's see what that error is talking about. Fail to resolve, do not find house in the create route, right? And what does that mean? That means something like this needs to happen. So I need to duplicate this, right? And you can see that it is gone. Do you get now? Now you can see the way they are like moving. So it can be a lot of like boilerplate creating and creating and creating, but there are other ways to do it. But if you can understand this pattern first, this pattern of you create this, you create this, you create this to get this, it makes it easy for you. So let's say even if you don't have this and then you have this structure, basically you already know how to import it. All you need to do is import the crate first as the root. Then from the crate, you want to talk about the house because this house is a folder, right? But you know that you need to create a file that defines what you get from the folder. Do you get? So the next thing I'm going to do in my main.rs is the house, which is this. Then remember the house is also a folder here. So this is telling the folder what to export, what it should make available for use outside of the folder. So in this case now, I already say that door should be made possible to use. And inside the door, there's a chair. So this will guide the way I even import my code. I already know what I want to use. But then remember that there's this pub mod stuff too, which is here, which you can have here. But then let's just leave it like this. I don't know if this is clear. So following this structure now, you can create something like this. You can, depending on the structure you have for your code, you can know how to import it and you can know how to manipulate your way around import and export. But if you understand this pattern of creating modules, like I said, it's going to be easy for you to pick up other kind of modules. I don't know if that is clear. Yeah, it takes a bit of getting used to, like in terms of folder structure. Yes, I understand that is normal, like it's normal. But then just try to see the way I've explained this, right? The first thing you need to do, you need to have your the file that specifies and that defines what you have in the folder that is going to be referencing that particular module you are calling. In this case, the module called garden. So that means if you have a module called garden here, that means the module called garden needs to be exist inside the same path as your main.rs or your lib.rs. And then inside that particular module that you define called garden.rs, you are making reference to another module. And it simply means that you are calling this module inside a folder. So that means for you to do it, there are other ways to do this, like I said, but if you understand this folder structure, it makes it easy for you to grab the other kind of structures. And you can see the other type of structures. We've defined different types. This is one of them, inline. You can see other types of those structures as something like this. Now, if you try reading this now, it will make a lot more sense to you. Now, let me try to explain this. Remember when we talk about, when we were reading this and I was just scanning through. Now, let me try to read this again. Probably you will understand this better. It says, if your module is declared in the root of your crate, right? Something, let's say lib.rs or main.rs, Cargo expects the file to be named either the module.rs or the module name / mod.rs. So it simply means that in this case now, you know that we are using this first approach. If you look at it, the module name, what's the module name in this case? Remember, we have inside main, we have what's the module name here, garden. So that means the cargo is expecting the file to be named garden.rs or garden / mode.rs. So that means it's expecting something like this or something like this outside. Let me just do this. So in this case now, if I delete this, let me delete this. I don't want to like show you different implementations, so it won't get confusing. That's why I'm sticking to one first, right? But if you there are certain rules to it. That's the point. You get there are rules to it. And in this case, now what this means is you can either define it this way or define it inside the module name itself as a folder, which is what is here. So you can use this approach or use this approach. So if you're using this approach, this can leave and to still work the same way. That's basically what this means, this part here. Now, if your module is a sub-module of another module, the file should be named the parent module / module.rs or the parent module / the module name / mode.rs. Do you get now? So now, and that way, that's how Cargo is able to make use of what you need. So in this case now, if I remove garden, right, from here, let me just say I delete garden from here, right? You see that nothing, this guy here should still work, the mode.rs. All I need to do is to make reference to vegetables here. And then you can see that everything works as before without any errors. So I can do the same thing for house. I move it into a module.rs, and inside this place, I delete this. And inside the mod.rs, I define pub mod door, and that's all. And you can see now that it's cleaner a bit, right? I don't know if you prefer this approach, right? But it's slimmer than what we had before. But now you have too many mod.rs. Do you get it now? So it depends on the approach you want. That's what I'm saying. So there are ways you can create these things, but you see that everything still works the same way. There's no error now in terms of the import. The only difference is that when you are creating your module like this, what you need to do is just create a folder, create a mod.rs inside the folder. I think if you prefer this approach, I don't know. Then you have mod.rs inside. Then the modules you want to, the files you want to make available outside of this folder, you need to specify it. If I want to make fruits available also, I need to specify it outside of here. So if I'm specifying it outside of here, then I can make use of it within my within this main function. But remember that this is not available because it's an unresolved import, obviously, because this doesn't contain anything. Yes. So it doesn't contain anything here. So I can call it mango. Right. But then this is still going to throw like an error because there's nothing getting it. Yeah. It says it exists, but it's inaccessible. Do you see it now? Now, the simple reason why it's inaccessible, you understand that because it is not public. So that means I can't access it. You get it now? So, but still, it's still going to give this particular error importing the struct instead, blah, 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 stuff. But don't worry about that for now. I'm just trying to paint the point. They'll show you something here, basically. So that's that. So depending on the way you are creating your modules can be confusing. Yeah, no doubt about it. I know, right? And that's why you can dedicate a whole day to explaining it. and you still get confusing because you are working with file structures and file systems and different things. But the moment you understand how it works, it just works. Now let's try something else. Let's try to create another project entirely, so I can demonstrate that. So we just create this project ourselves without like wasting time. So let's create a new one. Call it new animals. Right. So I'm going to create animals inside of this. And after creating this, I'm going to open this animals. I'm going to open this one also, this new project called animals here in my VS Code. And then all I'll do is I'll extend this, I'll move this to the left, I'll extend this a bit so it's clear. And then I'm going to remove this. Now we want to try creating our own modules ourselves. So let's say we have something like this within this code, right? I want to import. So let's say I have now just try to follow what I'm trying to do here. Like I'm just trying to pin something from top of my head. So I'll create something called animals inside of this, right? I'll call it animals. And inside the animals, I'm going to have or let me say no, I don't call it animals, let me call it pets. Right? And I'll call another one inside the same source, I'll call them wild. Right? That means there are two types of animals. You have the pets and you have the wild animals. Yes. So in this case now, inside the pets, if I want to define certain types, I can define different types of animals and call them, let's say dog.rs. I can define cats.rs, right? I know people use dog, so let me use dog.rs. Do you get? So these three things. Now inside the wild animal, I can define the lion.rs. I can define the hyena.rs. Do you get? I can define the tiger.rs. Now in this case, now I have all of these files. But if I want to make use of any of them, let's say inside the dog, I have a struct called dog, for instance. Right? And then I make this public so that I can use it outside of this place. Now, let's say I have all of this, right? Now, look at this, compare this to what I have here. Compare this to what I have in this place. You can see that it's looking at the same structure, right? Like looking like the same structure, basically, without anything quite different in terms of this and this. But now let's look at what we are trying to implement here. So now I have this dog.rs. Let me do the same thing for cats. Let me just copy, or let me just write it. And say pub mod cat, right? Just define it, just a struct for it, right? And then the same thing for dog. Now this is not like this is just an example, right? It's just something I'm taking from the top of my head. And we have pub mod dog also as a struct. And we have all of these things here. And then if I want to now, let's say I want to call the cats from my main.rs, how do I go about it? Like the first thing I need to do is use a use keyword, right? Now after the use keyword, what do I need to do? The next thing to do is to actually look for the name of the module I want to call. But before I call the module, I'll probably define my mode here and say mode. I want to define pets. I want to make use of pets. Do you get? That's what I want to do. Yeah, this one, because I'm not done with this. So I want to make use of pets here. So in this case now, I will now define the pets I want to use, right? Now I'll define the pets I want to use here. Sorry, please, just a minute. Okay, so okay, so now that means if I do this, I want to access this pet, right? I want to access this here. So remember that if I do this now, see the first, okay, let me even try. How do I want to get? I want to get dog, for instance. I want to make some reference with dog and the struct inside dog. But you see that this is the way I'm supposed to call it. Make reference to the dog struct because there's a dog struct in this place and it's public and everything is working. But why do I keep getting this error here? It's telling me now that I cannot resolve that. The compiler is saying it can't resolve the module. Why? Because it cannot find pet.rs or pet/mode.rs. Do you get? If I try a quick fix, it will tell me to create a module at this or create a module at this. So let me go with the second one. So I'll create a module here and I'll just do pub mod cat, right? I'll do the same thing for dog and I'll do the same thing for dog. Do you get? Now when I go to my main.rs, everything works fine. The same way, I can now import dog from here. I can import cat. I can import dog. Do you get now? Like, just because there's nothing inside this actually. Okay. Oh, there is. Why is this complaining? Oh, shish. All right, sorry. Just use that. Just made a mistake here, like calling this mode. Okay, so then I have this mode here, and you can see that within my main.rs file, I have this, right? Unresolved import for this and this and this. Now, let's say move on used import. I know it's not being used. Resolved this, importing struct instead. Cards, this. Okay, so let's just basically, do you understand what's happened here with this one? Let me just leave this up for now. We'll still come back to giving me this kind of import eventually. Right now, you remember what happened here now, just because I did not have the mode.rs or the pet. If I remove this again now, let's say I delete this, I'm going to get an error. Now, if I try using this again, let's say I try using the fix that is going to give me from VS Code, I can create the module outside like pet.rs, and from pet.rs, I can make reference to the dog.rs from here, and then it's going to work. So let's say if I do this now, right? Basically, you can see that there's no error again. Do you get? So there are different ways you can like match your modules. It just depends on the way you want to use it, right? If you want to use the one that if you want to use the one with the mode inside of it, you can remove the pet from outside like this. And well, I think most people prefer that one too. So let's just move with that one. So that way you can have your mode.rs inside. So you know that whenever you have the mode.rs means this is you're making reference to that module called pets. And that's the same thing happening at this point here. So let me add this. So that's basically it. So now looking at this structure, you see the way we just created our own structure, right? Basically, that's so it's just depends on your implementation and you get just the way you define it. So I don't know, is that confusing? Is it clear now? Is it confusing? Is it clear? Okay. So okay, I just assume that it is clear. I'll most probably assume because there's no question here. Sorry, are we getting this module thing? Because it's going to be very important when you move forward. That's what makes you understand. When you handle a code base with a lot of code, a lot of files, 100% assurance, in fact, 95% assurance, let me use that, is that everything is structured in this approach using modules, right? And you will see a lot of modules just flying up and down, and you'll be like, what is happening? But if you understand the structure of the file structure is very important. If you understand it, it will make it easy for you to walk around, like looking at what we define now. So if I come to my main.rs file, I understand by default that this is a module that has this file called dog, that has something within the file called dog also, which most likely is a struct or something. So it's just for you to understand the structure. Once you get this structure, it's just what mostly confuse people. But if you can move past this structure issue, you are most probably like 70-80% good with how to manipulate modules. Yeah, so because that way you are making it easy for the compiler to work, and also you are making it easy for it to provide solution to you. Do you get it? Yeah, question, Lancer. If you have a question.
Yeah, good morning. Thank you for your time.
Yeah, good morning.
I fairly understand the whole stuff. My question is how do you practice understanding the whole, because it's one thing to get the theory and it's one thing to like practice it. So
Yeah.
what is one way you can suggest you can go about practicing, or because I don't know, I'm fairly new to Rust and working on a large code base is not something I'll probably be doing at this point in time, but still I want to understand the whole module stuff. So what is one advice or one way you can give? I don't know if that makes sense. Thank you.
Okay. Okay. Yeah. So it does. What you asked makes sense. So what I always do, right? So the reason why I'm using this exercise for you guys was I'm using this Rust exercises, under exercises to learn Rust, is because you tend to see exercise that you can play around with. Now we are still going to make use of these modules in these exercises, right? So one thing you can do is you can pick up all of these files. There are a lot of them that profile you exercises you can use to learn. Like this is one of them. This 100 exercises to learn Rust is one of them. You can try hands on different things. They will tell you what they want you to do. So you just do it as an exercise to see if you can get it to work. So that way you're actually trying your hands on something that someone has created and wants you to work on to get it. Now, another way you can, the other resources, another of those resources is this Roslins. You can use Roslin also, Roslins. This, so there are different like places you can just try your hands on all of these things if you want to like actually see how they work, right? This is another one. Roslin is where you also tend to try your hands on those things. So you just follow the instruction here and you will see exercises that you work on for every single thing I've explained and those I've not even explained. And once you complete it, they will give you step-by-step guide, like do this, then do this. But then you need to now try your hands on certain things. They'll give you exercises to do. And once you can solve it, you will definitely have more understanding about a particular topic, just solving it. So that's the way it is structured, right? Another one is what's the name of this? Rust Labs, right? All of these resources are available like online, so you can just pick any of them. Like for instance, now this one we just give you like, okay, this is what you want to do. Does this thing make sense? Does it not make sense? With like detailed explanation. You can see how they explain a loop here, more like a mathematical table. Do you get? And like detailed. So in this case now, if you want to try your hands on modules, let's search for modules. Now you can see introduction to modules, right? You can see how they explain it there. You can see introduction to modules, declaring how to declare modules, invoking the modules, keyword for modules, and you can see collection of items that contain structs, function enums, see the explanation here. And then you will see that aside from the explanation, they'll probably give you something to do, an example that you can try. And then you can use any of these, whatever you've learned from here, you can now go back to using maybe the Rust links to now use it to try your hands on more things. Do you get? Another way you can then learn, there's another one, which is JetBrains. JetBrains provides you, what they call it now. They provide you this academy thing. Let me check. I think I have it opened. Okay, so I have, JetBrains have an exercise that you can try also locally. I just want to see if I can like remember the name. I don't remember the name currently, but then you can use it to learn. Yeah, learn to program. So they have a lot of that structure you can follow, just like the Rust links too. You get that you can use to learn it. So you can search for JetBrains Rust. I can't remember the name. I will try to remember and then send it to you. Okay, learn Rust. Yeah, that's the name. So okay, it's just based on Rustlin itself. Yeah, exactly. So it's based on Rustlin. So if you can complete the Rustlins, trust me, you probably have completed almost every kind of topic you cover here. Because Rustlins will provide you with exercises to try your hands on from like everything about Rust, from the simple concept to the advanced concept. So if you want to really practice a lot of things, that's where you get exercises from. Like make a lot of sense. Yeah, so that's that. I hope that answers your question.
Yes, it does. Thank you very much.
All right. So yeah, so let's try to like move. I think time is not on our side again. But at least if you understand this today, I'm happy that we do. So then we can then move next time. But then we've covered two things today, basically, not just about modules. We've covered visibility also, even though we've not talked about it in depth. Now let's look at this to kind of buttress my explanation. So we already understand that modules are collection of items, right? Just files that contains structs, like I said, functions. It can contain the norms, vectors, arrays. We've not covered vectors yet. So all of those things. So how do you declare a module? We already understand that you use the mod keyword. Why is this thing dark? Sorry, let me check something. Okay. So you already understand that you have the mod keyword, right, for defining the module. That's what you use for defining your module. And then you specify the module name. Now, inside your module, you may have other things inside. So these are like for inline modules, right? And then you can have structs inside the modules. You can have enums, different things. And when you want to invoke your modules, you can see that we invoke it using the module name, right? And the name of whatever you want to call, whether a function, a struct, an array that is contained inside the modules. So now there are keywords that you use for modules, and we have seen all of this. We use the mod to declare a module. We use the pub to make a module public, right? Or to indicate that this module is going to be public. Then we use this use keyword to import. Now you can see that it's just an import, right? So it's just import for us. So import the module in the local scope. Now, modules are declared by the mod keyword and are private by default. You get to see that we've seen all of these things in action. So it's not as if we are just reading it now. We have seen it because we've tried our hands, we've seen errors, we've seen it fail, and then we've seen it work also. So that's the idea behind the entire try your hands on it, you fail, then you try it, then you make it, then you get it, then you're happy. So that's the idea. So now you can see, you understand this now that they are private by default because you've seen an error from there. And you know how to declare it, you know how to import and export using the use keyword, and then you know how to reference them properly. Now, examples of what you can have, you've seen something like this. So we have a module, you can define a module called mod R like this. Now, this is an inline module, right? You understand that this is an inline module. And in this inline module, you define your module like this, and you have a function in the module called print statement. This is just a function in the module. Use this module within the main function. All you do is just add a print statement. Now, let's now go back to the original. Using this understanding, right? Let's now go back to the original before we go to controlling visibility within the same file. Let's go to the original one we started with, which is that this one. What's the name again? This very says, right? Now, looking at this structure here, we can probably create a project that looks like this very says. There are different ways we can create it. Now let's try our hands on it. We can create it inside here. We can find a module like this and call it Ferris, right? Says. Is it Ferris says? Yeah, Ferris says like this. And inside the Ferris says, we can have a function called says. Like this. And inside the say, we can have the body or code logic. That's all. So by the time we are using it inside of this place, we just have something like use queries, says. And now compare this to this that we have here. Okay, let me change it from says to say. Right? As you can see here, it's private. So what do we need to do? We need to make this public. You get now. Before I even do that, let me show you the error that he's talking about. Now, before we compare this to this, now compare this that we have here, use Ferry says, to what we have here. You can see that we can create the library just the same way the person created his own library. It's just structure, it's just modules, using modules, right? And then importing it. So that means the save function here has the same thing. So now in this case, its own save function has a reference to a message. A message is a string. So it has a reference to a message, has a width. A width is just a string, an integer based on what is here. And then you have a reference to a writer. A writer is a buffer writer kind of type. So now if we want to create something similar, we can make that a string. Like I'm just trying to make an example, right? And then you can use a UAT for whatever. You can decide to say message. I'm just giving an instance, right? And then you can have with like this. And then you can have, I don't know what this buffer write type is, but then it's the writer type. And then inside the writer type, you have a reference to the buff writer. Now the buff writer basically is something I define. So now looking at this, right? You know that I can create a library to work similar to what the person did. And you can see that it works the same way. I'm taking the same number of arguments, just like what the person is taking here. It's taking message, with, and writer. I'm also taking message, with, and writer. So if I want to use this function, it's just a way of me saying say the same way is use say, and then my code is expecting different three arguments, right, to be passed to it as a parameter that was passed here. So as a parameter that was defined here. So now the idea in this case is that you can create a project, right? Just package it like a library like this, and then you can just push it to a to the crate repository. And then people that want to use that simply just follow this pattern and then they use it. Why? Because it's just a module. Like you create it to follow a particular structure, then people can use it. Now, if you want to create it from this structure to the former structure we have, it's easily possible also, right? You can do that. All you need to do is just you can move this to a module, right? Within this part, you can create a folder for it, call it fairy says, and inside that you have a say.rs, right? And then just have a function. That's basically it. Do you get? So, but in this case now, if I want to, then you can see there's an error here, and the error here says that say is private. So that means even the function inside modules are private by what? Default. So modules themselves are private by default. The function inside the house, expecting this error here, are private by default. So let me import this. Yeah, so if I can import this. Okay, just an example though, but then you get what I'm trying to do now. So I was just trying to import something. It's telling me to wrap it in a writer, something. Okay, we are not doing that, but get the idea, just an example. So this is basically what we can have if you are trying to model it with what we had here. So I can import this from here. Okay, so yeah, we're not dealing with this for now. Do you get it now? So this is, we can model it with to look like this, our own predefined custom library to just following this pattern of modules. So now, as you can see, this is an inline module, right? This is just an inline module. And then we can have the same thing to work like, let's say we want to make it, okay, so we want to make it an external module too. It's possible. We just create a folder for this, just like we have pets, right? And then we're able to call it and then use it like this. So we can just do the same thing. We just call it the name and then we just make use of it straight without stressing ourselves on as to this is what this is or this is not what this is. So it's crucial for you to understand like one particular one first, then you can understand the other ones. So if you understand this folder structure kind of defining modules, it makes it easy for you to grab the other one, which is like inline, because this inline now is just straightforward. You understand what this is, like very simple. But then the folder structure can be quite difficult to understand. But if you understand it, you are good. Just every other one will just fall in place automatically. Do you get? So please, any question before kind of end the class? It's almost 12, 10 rather. I'm using my 10 laptop time. All right, so basically, I want to point one more thing before we kind of like round up the class from this part where we have controlling visibility within the same file using public. Now, you already understand that by default, anything in a module is private by default, except you specify it to be public. So that means the functions, the structs, the enums, the arrays, whatever you have inside the module is by default private. You cannot access it outside of that module, except you define a pub on it. So that means you are saying make it public. Now let's look at this now. It says controlling visibility within the same file using pub. The pub keyword makes the item public and visible outside of its scope. You already understand that I explained scope at the beginning of this class. And then that also means that you can call the function from another module. So now by defining it as public, you can call it in another module. So look at this public function, for instance, called fn name. Because you have something like this, you can reference it in main, just like we have for this kind of code, right? If we did not make this public like this, it will throw us an error here, telling us that yes, it is private, even though it's in the same file. I can see that it's literally in the same file. So I'm just using this to now explain what we have done and show you guys. So then you can see that this is here. Then you can see we are using public to control the visibility. Now, there are rules, like I always tell you guys, there are rules to everything you do in Rust. Everything in Rust has rules. If you can understand the rules of how they work and why they work the way they work, you have like done 40% of your assignments. Then you need to start mastering the syntax. That's the only thing that is more than very crucial. So in this case now, understanding the rules is important because modules have rules, right? Imports have rules, creates have rules, everything basically have rules. The syntax themselves have their rules. Struct has the rules. Do you get? So now let's look at the rules. Privacy rule number 1 is that there are 2 rules to privacy in this case. If an item is public, it can be accessed anywhere. That's the rule number 1. So that means within the main function or any other module, because you mark it as public. Do you get? And looking at this, you've seen an example of this. We've also tried our hands on this kind of example using these fairy sayings. So that means rule number 2. What is rule number 2 now? If an item is private, it can be accessed using its parent module, meaning it can be accessed within the module, but not outside the module. We already understand this. Like, I'm sure everybody knows this now because we've seen it in action. We've seen the errors. We've seen how to fix it, right? So it simply means that by default, an item is public, an item is private, but you mark it as public to use it outside of that module. So in this case, when you mark this item as private now, as public rather, you are simply saying that you want it to be used outside of that module. But if you don't mark it as public, it can be used by another function within that same module. So basically what it means is if you have something like this, let's say we have say, and then I can have another function here that say, don't say. Why say? And why say can just be something like say this, and then just passing the argument. What is that? Do you get it now? So in this case now, okay, sorry for the noise. So in this case, we have this C, right? And you have YC, and you can see that you can make reference to YC from within this code without any problem. Why? Because it is within the same code. Oh my God. No, not this. So let's just leave this now. We are not making any reference. We are not making any call at this point. So now just we have this C, right? And then we have YC. And then so sorry for the noise, the background noise. Jeez. Where it's coming from. So we have this C, right? And you can make use of C within the same module. It's usable within the module, but not outside the module. So in this case now, you need to mark this as public, right? If I mark this, if I remove the public from here, this can still use it conveniently, but this will not be able to use it, even though it's in the same file. So that's what this is basically referring to. So in this case now, it says, if you have an example like this, a public function name my public function and a private name my private function, self can refer to a function or any item within the same module. So let's say we have something like this. We can use self to refer to this private function. So something like this now, self, like to refer to it, because you understand that it's it's within the same module, right? So then we can make use of it because they are within the same module. So whether private or not private, you can reference functions or whatever you define, items, struct, enums, arrays within the same module, but you cannot reference them outside the module. But whatever you reference within your module can still be called outside of your module. So let's say in this case now, there's a private module here. The private module is passed into the public function. The private function is passed to the public function. By the time we are printing this, it's going to appear here, right? Because what is calling it is not the main function directly. It is the function within the module itself that is calling it. So that way you can make reference to it. So that's just basically the That's the idea. So I think that basically just clarifies everything about modules for now until we start doing stuff about it also. But then let's try to finish this, wrap this up before we round up the class. So an example is access. So when you want to access a private function through a child module, right? So these are more complex ways of like implementing modules, right? You can have nested modules in this case, just like what we have here. You can have nested modules. And so let's see how that works. So if there's a module within a module, then the outer module is called the parent module. And the module inside the module, the parent module is called the child module. This is known as a nested module. Now, the example declares a module mod outer module, which has a private function called my private function and an inner module, which has one public function. Now, this following example shows how the private function is accessed in the child module using the keyword super, followed by the colon, right? Now, how do we do this? Now, let's try to analyze this. We already understand how modules work now, right? Inline modules as well. So we have a function here, which is the main function. You know what that does. And then the main function is calling something. And what is it calling now? It's calling the outer module, right? The outer module is this module here, right? The outer module is calling an inner module. The inner module is this module here. Now, the inner module is calling my public function, which is a function that exists within the inner module, which is this. Do you see? So everything works. Like, so this import is fine. But what it's saying here is that how do you access it now? How do you access something that is in the parent module? Now, this is a parent module, right? Outer module is a parent module because it contains another module. It takes in another module called the inner module. So this outer module or the parent module has a private function which cannot be accessed except you specify the public keyword or you call it within another public function within the module. And then you can declare a nested module in this case, which in this case means that you have public module. Now, remember that inside this outer module, the outer module is private, right? Because there's no public there. But the inner module is public. You can see that's a pub keyword. So now the inner module can be called from the outer module because it is public. Do you get it now? And because you mark it as public, the function within it also, you want to call it. So you mark that function too as public. So marking both of them as public gives you access to be able to make reference to them. So what do you do automatically? Because you've done this, now what you now do is you can now call any of these things inside here and they will be called. But then how do I call this private function that is outside of the module? Because if you look at the structure, private function is outside of the module. It's not within the inner module. So one of the ways or the way to reference anything from the parent module is to use the super keyword. If you use the super keyword, everything will fall in place from there. You can make reference to it. The super keyword is common in other programming languages, like you can use it in languages like Python is common there. You have the super keyword whereby you can reference a parent module. It's always used for parent modules. So the same applies to Rust. Rust gives you the ability to create make use of such things also, whereby you can reference a parent module. You get it now from within a child module. So the super simply means reference what is outside and give me access to it. So that way everything will work fine. Now, how do you access a root function now in this case? Now, this is the last thing for today before we call it a class. We have access a root function. Now, this example below shows how the root function can be accessed within the function of a module. So let's say, for instance, we write super followed by this. Let's look at this. So we have this function, which is the main function, right? This is perfectly okay, right? But inside the main function, we have this my module and referencing my public function, which is perfectly okay too because it is marked as public, so it will be called. Now, this public function wants to call a function that is inside the root that is inside the binary crate, right? It wants to reference something inside the binary crate. Now, how does it do it? Now, it needs to also use the super. The super can also work in this case to reference something from the root. Do you get now? So if you want to make reference to something from the root, you can use the super as well to make reference to that thing. Whether it's in the binary crate or the library crate, you can still make reference to it using the super keyword and everything will work just fine. right? So that's basically how you can, control visibility within the same file. And the same applies to within different files also. Like it's basically just the same thing, right? You can see explicit, you can see this, you can see all of those things. This is actually even smaller than the previous one. So you can declare your module like this, you can call the module like this, you can declare it explicitly like this, and you can call it like this. Now, do you see the difference, right? So if you define it implicitly like this, right, you can call it like this. If you define it explicitly like this, you can call it like this. So it's not, it's just basically just as simple as you can think of it. It's not too crazy, it's not too complex. So that's just the idea about it. So privacy rule, we already understand the privacy rule. You can look at an example. So you can still go through this again if you feel like it's not clear enough. But using the understanding that we already have from our examples, right? You can easily use this to like buttress it, and you can go through the video again. I'll share the video to you guys, or you can check it on the YouTube channel. I always drop all the videos. Everything is there. You can always make reference anytime. And it will be there by the end of today, most likely. When once it's dropped, for those of you that are subscribed, you will see notifications too. Or if you've not, just check it this evening, you will see it there. So you can always go back to like check it and you will see it there. So that's basically the thing about modules. Like it takes a lot of things to understand it, right? So, but once you get it, you've gotten it. That's just the beautiful thing about it. And then that's the first step to like understanding how to properly structure your code, how to like implement modular code, or how to structure your code in a modular way. You can even then read and understand other people's code, right? Without causing a dependency or what do they call it now? Cyclic error. Is it cyclic? Okay, cyclic yeah, import error or something like that within any file that you're trying to contribute to or stuff like that. So that is what modules are basically. So yeah, that'll be all for today. Any question before maybe there's anything that is not clear that was spoken about? You can always go back to like touch on them before we end today's class. We've gone past just a few minutes. Sorry about that. So any question from anybody? Any question at all? Okay, so I assume there are. Yeah, it's going to
No,
be presented.
sorry.
Yeah, the same one. The same one. Yeah. Yeah, you have a question. Go
My,
ahead, please.
my question is, how can I like get the recording just for like revision purpose?
Okay, so there is this. Let me drop the. So there's a YouTube channel that I post it every time. Let me drop the link here. Link to the YouTube channel. So yeah, this is the YouTube channel. So I always drop it here. There's a playlist. I just compile everything into a playlist, right? That you can watch. Like, so the 3 classes we've done. What is this? The 3 classes we've done is basically inside this. How is the last class not inside here? But basically, this is the channel. Like all the playlist for all the classes. You can always check it there. It's there. So I'll paste the link here. So you can go there, you can check it out. And today I'm going to paste this one also. Today's class, I'm going to upload it today. Once I get it back from Google, I'll just like try to compress it, then push it and all of those things to make it suitable for like YouTube stuff. So once I push it, you can always get it. Like you can always get notified. I always get notified when I push my videos to like because I'm subscribed to it. So you can always see it there. You get so all the previous videos from the previous classes are there and see it. So yes, that's any other question? Everybody. So it's basically not like it's not a boot camp, it's just more like a so it's just a class basically. Look at it like a class whereby you come to learn Rust like for free, no strings attached. Because fine, people want to learn it, and I have a lot of people that want to learn from me. So I just decided to make it open to everybody that wants to know about it. So that's why it's open. It's not a boot camp or anything. It's just a free class, open class for anybody to join. So So yeah, the WhatsApp group, right? Let me do that now. I've always wanted to, like I said last week. Okay, I'll drop that. I'll drop that. There's no YouTube link because, of course, because of managing it. Like I said last week, I don't want to create a YouTube page and I don't do anything there. So, but let me create one. I think so that I have the time. Let me just drop it. So, um, I'm coming to this. There is no YouTube yet. There's no WhatsApp group yet. Let me drop the resources, all of them, first of all. And what I'll probably do is I'll compile this to like if an online file, like more like a website you guys can always pick anything from. So I should have deployed that, but I was kind of like booked up during the weekend, so I couldn't do that. But I'll try to get it done this week. Before the next class, there will be a place where you can always access it, a ready repository where you can access all of these things and you can make use of them. So let's see, what's the other resource? The other resource is this one. Yeah, Rust Labs. And then the last one is Roslins. Roslins.cool. Roslin is cool. So yeah, you can. Yeah, I'll create a WhatsApp group. I'll create that. I'll create that, and yeah, I'll do that. I'll do that, and yes, everybody can join. But like I said, I'm going to create a WhatsApp group. I'll just release a link. Also with the so on the video, like when I upload the video, I'll drop the link to the WhatsApp and the, what they call it, the website that you guys can get information about it. So everything you need to do, like okay, you want to add this call to your calendar, you can do that. I'm going to share that link today. Okay, I'll start working on it after this course. So that you guys can like download the Google invite for this call every Monday so that you can get notified, yeah, before then. So I'll just create that page. Then that page will also contain the um WhatsApp group once I've created it. So I'll do all of those things. So yeah, Judith, is that fine? All right. All right, so that's that. And yes, Anulu Akpo have dropped the resources so you can use it. And yeah, so in the absence of any other thing, I think we can call it a day from here. Thank you so much, guys, for joining. I hope you've learned something today, one thing or the other, no matter how small. I hope it was not too much for you guys. I know it can be a lot sometimes, but yeah, just you keep pushing. That's the idea. People are speaking arigato here. It's where all the anime fans. All right, so thank you guys. Thank you so much. See you guys next week. Right. What questions